Hello everybody and welcome back to my Applied Data Science channel. My name is Joanna, I'm a senior data scientist and I can't even express how excited I am to be making this video, because through it I want to empower you to showcase and share your machine learning models with prospective employers, customers, or even just with your family and friends. I want to give you the tools and encourage you to build a portfolio of machine learning projects, and this is going to develop a different set of skills that go more into the machine learning engineering side of things. Once you will see that your machine learning model is running in the background of a web application, you'll have the desire to do it over and over again because you will be able to actually showcase something. Because doing everything in one go would result in a too long video, I've decided to split this project in two. And in this particular video, we are going to focus on how to go from a Jupyter Notebook to a machine learning API. And then in a second video that will follow, we will go from a machine learning API to building a web application and connect those two. What are we going to cover today? So we are going to build virtual environments, and if you're not familiar with what virtual environments are, then I suggest you would just go to my video on virtual environments where I explain their importance and how to create them also. Then we are going to build our API using a layered architecture just to work as close as possible to a real-life scenario. Then we will build a machine learning API. We will also go through sending requests to that API and test its functionality. We will work also with GitHub and we are going to publish the code on GitHub. Then we are going to deploy the API using a free hosting. What we won't cover in this video is testing. Then we won't Dockerize the application in this video, and we will also not build the user interface. Okay, so we are going to start with creating a GitHub repository. If you don't have a GitHub account yet, then I suggest you create one, and there are some tutorials on YouTube on how to set up everything on your computer. By pressing new, we can create here a new repository, which I'm going to call price of apartments app. Okay. Here you can write a description if you want. You can add a README file. That's something that I suggest you do. And then set the repository to public. Then we are going to create a repository. Now we have our repository, so the next thing we are going to do is clone our repository on our local machine. And there we are going to start writing code, and then at the end we can push that code here in the cloud. So I copied the link, and now in my VS Code terminal, I'm just going to say git clone and then give the link to my repository. And my repository was cloned in the folder Giraffe. Okay, so now if I list this folder, I can see that my price apartment app is a folder inside my root directory. So I'm going to change the directory to price apartment app. And here is where I'm going to actually start to build my application. So now the first thing that I want to do is go and open a folder, and I want to open exactly this folder. So from my Giraffe folder, I'm going to open this particular folder, which, as we can see, only contains a README file and it is empty otherwise. The first thing that we are going to do is create some folders that are going to respect the layered architecture convention. So we are going to build a domain folder. Here in the domain folder, we are going to define our request and response classes. Then the next folder that we are going to create is service. In service, we are just going to put the workflow of the application. Then we are going to create a Python file which is called app.py. We are going to also build a user interface folder, but we will not do anything in it for now. Okay. I guess that's it for the moment. So the first thing that we'll be doing is creating a virtual environment. And to create a virtual environment, we need to use the module venv. And now just name our virtual environment as we wish. So we will call it venv price. So now our virtual environment is creating, and we can see that there is a new folder here which has the name we've defined already. Okay. And in this virtual environment, because this is a Windows machine, we have particular folders. These are going to be different on a Linux machine, but again, you can just go and check the video on virtual environments, how to create them and how to activate them. So for this particular Windows machine, we are now going to activate our virtual environment by just going here in the scripts activate folder. And we can see now here the marker that we are working inside the virtual environment. Good. So now that we've created our virtual environment, this doesn't have any libraries pre-installed. So we are going to have to install all the libraries that are required to create this API. As I said in the description of this video, we are going to start from a Jupyter Notebook to create this API. And the Jupyter Notebook that we are going to start with is going to be our random forest regression Jupyter Notebook. So this is something that we've built in a previous video where we were trying to fit a model that predicts apartment prices based on particular criteria. We first tried that with a linear regression, and then then we managed to beat the performance of the linear regression by using a random forest regression. And because this random forest regression is going to be our best model, we are just going to use that for deployment. Just to briefly explain what we did in this Jupyter Notebook. So after loading the libraries, we loaded the data, and then we inspected the data set. We saw that there are some inconsistencies in the columns, and then we had to change the data types of some of those columns. Mainly, we changed the data types of the string columns into categorical columns. But first, what we did is converted the strings to numerical values. So we encoded the labels, and then based on that encoding, we changed the data types to categorical. Then we found one outlier and we dropped it, and then we generated the train and test sets. In the end, our model, our best model, only included a set of 5 predictors. So these are going to be the predictors that we are going to base our price prediction on. And these are those that we will include in the API. So we will predict the price of an apartment based on the number of rooms the apartment has, based on its size in square meters, the number of bathrooms, based on the neighborhood in which the apartment is located, and on the year the building was constructed. And the neighborhood was a string variable, and we performed the data type change on this variable. The rest of the variables were left unchanged in terms of data types. And also the price in euros was left unchanged. Okay, then we split our data set into train and test and trained the model. Then we checked the performance, and at the end what we did is we saved the model. I want to show you this. So at the end what we did is we saved the best performing model in a pickle file with open. So we dumped the model in this pickle file that we saved. When we build an API, what do we actually need out of all these notebook? Because an API is actually a prediction service, right? So in the case of machine learning, and particularly in this case, we are building a service to which we are going to send new data in some format, and then the API is going to do the processing of that data and the prediction, and then it will return us the prediction. So we will send a request and we will get a response in terms of the prediction that the model outputs. So what's important for our API to work as expected is, first of all, to contain the prediction model, of course, because that's the core of the machine learning API. But besides that, to do all the data processing that was performed before actually inputting the data in the prediction model. So besides just saving this best model as a pickle file, what we are going to have to do is also check the variables that we included in the model and see whether before inputting these variables in the model there was any data type requirements or data processing performed, and then include those steps in the API. And as I said, we had this neighborhood variable, which initially was a string variable, and then we transformed this variable to a numerical categorical variable. So with each number encoding one neighborhood. And we are going to have to map the neighborhood when we send the data to the API exactly the same as we did it in this pre-processing step when building the model. Let's go through the steps of pre-processing the neighborhood variable, as this is going to be the only string variable included in our model or in our final model. Okay, so first we lowercased the values of the variable, and then what we did is we initialized a label encoder, and then we fit transformed this data. So if we were to check the data, how it looked before, we see that we have these strings which are lowercased. And now, after applying this label encoding to our data, we can see actually that the data is now numbers, with each number corresponding to one of the strings. So each number corresponding to one category. So now we will have to save this label encoder for later use. And how are we going to do this? Well, we will save it in a pickle file also, the same as we saved our model. And we will write in this binary file. So we just specify WB. And then what we'll do is pickle dump. With pickle dump, we specified exactly what are we going to dump in the pickle. We've also saved our label encoder in order to preprocess the neighborhood variable. And we are going to create here a new, not in the venv. Here we are going to create a new folder which contains artifacts. And we are going to just copy our label encoder file as well as the model file. And now we have everything here. Okay, so now the first thing that we want to do is define which is going to be the input for our request. And the input for our request, we are going to take it from this x variable. So we are going to send values to the API for each one of these predictor variables. And then the API is going to return a numerical variable, a numerical value, which is the price in euros. So then in domain, we are going to create a domain.py file. We are going to use the base model from the pydantic library in order to define our request and response classes. In order to actually be able to use the pydantic library, we'll have to install it. And as you can see, I'm installing the pydantic library as well as all other libraries that I'm going to need in my virtual environment, because this is where I'm working. I am also going to create here an init file, because I'm going to use this domain as a module and import it in the next files. So from pydantic, I'm importing the base model, and now here I can build a class which is going to be called apartment request. So with this class, with apartment request, I'll have to actually send data to my API. And the data that I'm going to send to my API is going to be values for the predictors that I used in order to build the model. So as I used number of rooms, size of the apartment, bathrooms, neighborhood, and year the building was constructed in, I'm just going to define exactly the same attributes when creating the request class. So the number of rooms is going to be an integer, then the size of the apartment is going to be an integer as well. Then the number of bathrooms is going to be an integer. The neighborhood, so how do I want to specify the neighborhood? Well, I'm going to specify the neighborhood as string, exactly as it was also specified in the original data set. And then I'm going to convert the string to a numerical variable using the encoder, and then that numerical variable I'll convert it to a category, and only afterwards will I input it in the model. And then the year the building was constructed in is also going to be an integer. The next step that I'll have to do is define the response. Sorry, so I've just realized now that this inherits from the base model. Yeah, that's why I imported base model here. And also the response inherits from base model. Okay, so the response is just going to be the price predicted by the model. So I'll just say price, and it's going to be an integer. So now these are the classes for requesting something from my API, and then respectively from returning a value from my API. So now that I've defined my domain, I'm going next to define the service. And here in this service, I'm also going to put a Python file, which is called apartment service.py. And I'm also going to put an init file, because I also want to use this apartment service as a module. And by placing init here, I'll be able to use it as a module. If I go here in my notebook, I can have a very clear indication of which are the libraries that I'm going to need in order to build the workflow. So I'll install pickle with pip install pypickle, then pandas. I don't need numpy, I think. I'll see. But then I'll need the label encoder. For the label encoder and the random forest regressor, I'll need scikit-learn. Then I don't need any kind of visualizations, nor do I need any metrics. So in the apartment service here, I'm going to, actually, I'm not going to install numpy for now, but we'll see. Okay, so I'll do pip install pickle. Then I'll do pip install pandas, also in my virtual environment. Then I'll do pip install scikit-learn. The next thing that I'll have to import is the classes that I've defined here, the apartment request and the apartment response. And because this is a module that I've created, and these are classes that I've created, in order to import them in this different file, which is in a different folder, I'll have to export the Python path and set it to my project directory. So I'll say C user documents giraffe, and then price apartments app. Okay, and now that I've done that, normally I'll have to be able to import from domain. Import apartment request. Okay, so let's see if that works. And now we'll give it a try. Okay, and now the file executed. Awesome. So besides apartment requests, I'll also have to import apartment response. Okay. So now the next thing that we'll be doing is, now that we've installed all these libraries, we are going to define a new class, which is going to be our apartment service. Okay. And this apartment service, we are going to start it by defining the init. That. And now here we are going to pass in some attributes. So first we are going to pass in the path to our random forest regressor model, so the path to our prediction model. Then we are going to load our model also in the init. And this is going to be done with a function that we are going to create. Okay, so now let's define this function that loads our model. Define load model. And it's going to take in one argument, which is the path to the model. Okay. And what we are going to do is use with open. We are going to pass in the path to our model, and we are going to read this as a binary file. And then we are going to use the pickle library to load our model. And we are going to say this is model. Okay, and then this function is going to return the loaded model. Okay, so this is our first function, which loads a prediction model from a pickle file. Namely, it loads our random forest regressor. Okay, the next thing that we are going to do is to load the encoder. And for that, we are going to actually, you know what we are going to do? We are going to say that this function is load artifact to make it more general. Then we'll say path to artifact. And then we are going to load from a pickle file. Okay, so we'll have to change this to path to artifact and then return artifact. And the reason I'm doing this is because actually we'll have to load two pickle files. And for one, we are going to load the model, but then we are going to use exactly the same code to also load the encoder. So we will load the artifact here, which is going to have as input the path to our model, but then we will also define the path to the encoder, and this is going to be let's see how we've named it, neighborhood encoder. And now we are going to use self label encoder, which is going to actually use exactly the same function, which is load artifact, but this time we will just pass in the path to our encoder. Okay, and also here I forgot a self. Okay, so now when initializing the apartment service, what's going to happen is that in the initialization phase, The prediction model is going to be loaded from the pickle file that we specified here in the path model parameter, and then the encoder, the label encoder, is going to be also loaded from the specified path. The next thing that I want to do is create a function that is going to have the data ready to be input in the model in order to predict on it. So if you remember, previously when we created the random forest regressor, we split the data set into data frames, into smaller data frames. One of them was used for training, and then one of them was used for testing. So our model is used to take as input a data frame. So even if we are going to only pass in information regarding one apartment, that information has to be in the data structure of a data frame. Then another point that I want to mention is that this new data frame needs to have exactly the same columns as our model was trained on or was used to get, which are these 5 predictors that we've defined here in the apartment request. So now what we are going to do is create this function that pre-processes the input, and this input is going to come from a request. Yeah, this request is going to be of type apartment request that we've defined previously, and this function is going to output a data frame. Using this kind of syntax is very helpful for the clarity of the code, because now we know what type of data we input in our function and what type of data are we expecting our function to return. So we will input an object of type apartment request, and we are going to output a pandas data frame which will have 1 row and 5 columns, each column corresponding to one of the predictors that we've defined at training time. Okay, so now, as I said, in order to create this pandas data frame from our apartment request object, we'll first have to put the information from the request into a dictionary and then convert that dictionary to a data frame. And then on the data frame itself, we could then perform different transformations. For example, lowercasing the neighborhood values and then encoding the values of the string corresponding to the neighborhood column and respectively transforming it to a categorical variable. So first of all, then we are going to create a data dictionary. And this data dictionary is going to have all these columns that we are using for prediction, which actually we've already defined here in the apartment request. So it will have the rooms, then it will have the size. These have to be column names exactly as they were previously at training and testing time. Yeah. So we have to keep the naming, bathrooms, and then neighborhood, and then the last key in our dictionary is going to be the year built. Another mention, please keep all these columns in exactly the same order that they were provided to the model at testing and training time. So no creativity at all here. Okay, so now where are we going to take these values from? Well, we will take it from the request, because we can access them from the request by using dot and respectively exactly the name of the attribute we've defined in our class. So by using request.rooms, we are accessing the value that this attribute has in the apartment request object. I'm going to write these on separate lines for better visualization. So here we have the size, then we'll have the bathrooms, the neighborhood from request, and then from request we are also going to access the year that the building was constructed in. So now we have this data dictionary, right? So now from this dictionary we can create a data frame which has only one row and all the column names of our dictionary keys. So we'll say data frame is going to be pandas data frame, and then we have the method from dict, which is from dictionary, and now we'll have to pass our dictionary inside a list because our dictionary only has one value for each one of the keys. So we'll have to specify somehow that put everything on index 0, so on the position 0 of the data frame. And here we are just going to give as an input the name of our dictionary. So now we have also the data frame, which only contains one row. Probably this is a little bit difficult to follow because unlike in a Jupyter Notebook where we could run a cell and then observe the output after each one of these steps, here when we are working in a Python file, we don't do that. But nevertheless, if you just want to double check if your syntax is correct and performing as expected, you can just go inside the notebook and then run all these things inside the cell. It's no problem. And I sometimes do that. Okay, so now that we have our data frame, we remember exactly what are the preprocessing steps that we performed on our data. And on our data, what we did was, first of all, we selected the neighborhood column. Just access it like that. And the neighborhood column, we lowercased it. So this is a pandas series, and we can lowercase it like that. And we are overwriting the column, the values inside the column. The next step that we are going to perform is use the label encoder in order to convert this lowercase string to a corresponding numerical value. In order to do this, we are going to access the label encoder that we've defined here inside the init. So we see that self label encoder is actually the label encoder itself, and we are going to transform the value of our column such that it matches the predefined encoding. And after we've done that, the next step is to convert the data type to a categorical data type from numerical data type. And for this, we are going to use as type and category. Okay. Then we are going to return our data frame. This is ready to be input inside the model in order to get a prediction. If we want to test if this code works as expected, we could do the following. So if we are going to execute this particular file separately, we are going to say if name is main. So this is the condition that I've stated before. Like if we are going to execute this file, then what we are going to do is, first of all, initialize this apartment service. And then, not as, okay. And then from this apartment service, we can just call the preprocess input, and inside the request we are going to say test request and then we'll print the data frame that was returned, print the data frame that this method returns. Okay, so now let's see what's our test request. Yeah, our test request is going to be an object of type apartment request. And now for each one of its attributes, we can just input some values. For example, assume we are going to test for an apartment which has 2 rooms, which has 54 square meters, the number of bathrooms 1, then the neighborhood is going to be like this one, Mănășturi. That's a Romanian word. And then the year built is going to be 1990, let's say. Okay, so now we have this condition here, and if we run this script, okay, then we can also debug. Okay, no such file or directory. Okay, let's check why. So we are going outside of the service directory. So here I have instructed actually the program to get out of the service directory by putting these 2 dots and slash, but I've previously set the Python path to be my project directory. So then I don't have to instruct my program to get out of the service, because automatically it will run the program considering the project folder as the root folder. So then I'll just have to just specify this relative path, and then here I've realized that I had a typo. Okay. So now I'll get rid of these errors. Okay, and now I see here that I have a data frame after running the preprocess input method inside my apartment service class. This is exactly what I'm expecting. Yeah. Okay. Now I'm ready actually to define the function that is going to predict the price. And as an input for this function, I am going to again consider the request. And it is going to be an object of type apartment request. But this time, the output from this function is going to be an object of type apartment response. The first thing that I'm going to do inside the object, inside this method, is going to be preprocessing the input. I'm going to call this input data, and then I'll call my method preprocess input. And my preprocess input takes as a parameter the request. So I'll just input the request here. And out of this, I have my data frame. So maybe I just call this input data frame to be more specific. And now it's time to predict. It's time to predict. My model is already loaded in from the initialization of the apartment service. Yeah. So I'll have this self model. So now if I'll run predict on self model, and at prediction time, my model takes the input data frame as a parameter. This is going to return me the price. Okay. But actually, this is going to return the price as a NumPy array. So probably I'll just have to extract the value from the array and then return the apartment price. And then return the apartment price. Well, no, I'm not just going to return the apartment price. I'm going to put the apartment price inside my apartment response object. So I'm going to initialize the apartment response. And now the response.price, which is exactly how I've called my attribute in the domain response price, I'm going to set it to be the apartment price. Okay. And now I'm going to output, so I'm going to return the response. Okay, so now if I also want to test whether the price is predicted correctly, then I'll just go here and change the method to predict price, which also takes as input a request. But now this time I won't have a data frame. I'll have an object that I'll call result, and then I'll print the result dot price, because I want to access from my object of type apartment response just the price and see if the prediction is correct. Okay, so now I'm going to run this script and see if it has any bugs or it runs smoothly. Okay, cool. So it seems that my test apartment would be advertised for 125,000 euros, approximately. Okay, cool. I'm going to comment out this. And now we are going to jump into actually creating the API. And we are going to do that here in this Python file, which is called app.py. And in order to create an API, we are going to use the FastAPI library. Again, we are here in our environment. We are going to pip install in the environment the library. we're also going to install UVcorn. We are going to proceed with importing FastAPI. We are going to create our FastAPI API. Price app equals FastAPI good. And now we are going to create a post method. We'll use the decorator price app post. Okay, so we are going to say, okay, predict here. And here we are going to define predict price, which is going to take as an input from domain the apartment request, and it's going to return the apartment response. It's going to get a request. This is an object of type apartment request, and then it's going to output an apartment response. What's going to be inside this function is actually going to be our apartment service predict function. So from service apartment service import apartment service. And now, as I said, inside this function, we are going to say apartment service predict price and pass in the request as the parameter. Okay. This is what it is going to return. Okay, so I've made this larger, a little bit larger, so we can see exactly how we are going to run our application. We can use the UVcorn command and then just here add the name of the file where our FastAPI is defined, and then the name of the API. And now this is going to run our API. And now our API is running locally on localhost. So what I want to show you is if we use this link, then docs, this is going to open our FastAPI documentation. And here you can see exactly which is the schema of our API. We can see here how our apartment request looks like, and then how our apartment response looks like. And what we can do is even test our application. So we can go here to try it out. And then here we can input some parameters. So this is the request body. As you can see, our request is in the form of a dictionary with each key belonging to one of the attributes in our apartment request object. So here we can say, we can input as a test the number of rooms, the squares meters, the number of bathrooms. Here we will input a neighborhood, and then here the year the building was constructed in, and then we press execute. Now we'll have to go and debug our application a little bit. So if we go here in the terminal, actually we have the reason why our apartment crashes. It says the apartment service is missing one required positional argument. So probably I've done some typo. Okay, so I forgot to put the brackets. Okay, so now if I'm going to run it again and exit this and then run again. Okay, so now let's see if we have, oh no, we have another error. Okay, no problem, let's see. Okay, int from float. Input should be a valid integer, but got a number with a fractional part. Okay, so here the problem is that we haven't converted our output to be an integer, such as the price, such that the apartment response requires. So we'll have to go back here in the service. And now here, after we have predicted with our model, it seems that the model is predicting a float value. So if we want to pass the data validation from the domain, we'll have to convert our apartment price to be an integer. Good. Now we've updated our code, and we are going to try once again to send a request. We will try exactly the same. See if this works. And now if we press execute. Okay, and now if we press execute here, we see that the server response is successful. We have code 200, and then also the price is predicted for our test apartment. Yoo-hoo! So locally we have this FastAPI working. Another way in which you can test an API is using Postman. Don't know if you've ever heard of this application. First, I'll have to check which is the URL and the port on where my service is running. So this is localhost. And then I'll input this here. And then after specifying the port, I'll also have to use this -predict, this /predict in order to send a request to the service. I have the rooms. Let's see, 3 rooms, for example. The size of the apartment, it's going to be 54. Then the bathrooms are going to be 2. Then the neighborhood, this is going to be Rigorescu. And then the last key value pair, the year built, this is going to be 2000. And now I can just send my request, and here I'll have the response. The response is successful. It indicates the 200 code also. So this is another way how you can actually test the API locally. What we'll have to do next is to create a requirements file in which we are going to specify all the packages, all the libraries, and their versions respectively that we have installed in our virtual environment in order to be able to run this application successfully. We are going to use pip freeze And then we are going to call our file requirements.txt. And now we see here we have a requirements file, and the content of this requirements file is exactly all the libraries that we have installed in order to run this application. The next thing that we are going to do, because we will upload this code on Git, we'll have to also create a git ignore file. And now inside this git ignore file, we need to put all those folders or files that we do not want to be visible, that we do not want to push in the repository, in our public repository. So first of all, we are going to not push this pycache folder. Also, we are not going to push the virtual environment. So now that we've also created the requirements file and we specified what we don't want to push in the Git repository, we are going to push the code. I'm going to show you how to push code in case you haven't done it yet. So we are here in our folder which we've previously cloned from Git with git clone and then that URL. So now what we can do is use git status to see exactly which are the changes that we've done to this repository, right? And once we've identified all these changes, we can decide what we want to add to the queue for further committing and pushing in the Git repository. Like what do we want to make public from what we have here, from our changes. Now we are going to push everything in the Git repository because we need everything. So we'll just say git add dot, which dot means everything, okay? And now we are going to git commit. And -m, we are going to set a message with which we are going to commit these changes. So now all these files are ready to be pushed. To push the files, we will use git push. I've pushed my code in my GitHub repository that I've created at the beginning of the video by using git push. And now what I want to do is to check if indeed my code is here in the repository. And indeed the code is here. So now I can see that instead of having this empty repository, I have a repository which contains all the files and folders that I have created today. Now it's time to deploy the application, and for this I'm going to use Render, because Render is a free hosting service and you can host a machine learning application there without having to pay anything, but you can also choose a paid plan if you want to. I have already created an account, so you can also create one account on Render, and then you can just go here, press the new button, and to deploy this API, we are going to create a new web service. Here we are going to just input our Git repository. So here we'll pass in the link. Then we press connect, and then we'll have to choose a name for our application. Then we'll need to, I'll choose API, then we'll need to specify the Python version, the branch where our code is in the Git repository, and then here we'll have to find the region closest to us, which has servers that our API can be deployed on. in the root directory I don't specify anything because the git root directory is actually my home directory or my root directory. And then here I'll specify the requirements that I want to install, which are going to mimic actually my virtual environment. And now here type in the command that's going to run my API, which is uvcorn app price app. And I'm also going to specify the host, which is going to be 0000, and then the port, which is going to be 8000. So where my API is going to run. And then I'll choose the free instance. I don't need any environment variables because I don't have any like credentials that need to be inputted. And then API price apartment API. Okay. And then I'll just press deploy web service here. Okay, and now I can see that the deployment has started, and this is going to take some time, so I am just going to come back after the service has deployed. Our API is live and running, it was deployed, and you can actually start to send requests to the API by using this link up here. So if you copy this link and now you go to Postman again and you send exactly the same request. Okay, so I'm going to put it up here. So if you send exactly the same request, but now this time instead of sending the request on our local host, you just input this link that you were offered up here by render, and if you, for example, run exactly the same request as before, now, yay, you have a price. And this is because your API is running live now online. So you can actually use it next to build a user interface and to build a web application and have your API running in the background, estimating the price of apartments. I really hope that today you learned something new and that you feel more confident in trying to build your own API, having your own machine learning model inside it. Next, we are going to build a user interface for a web application that's going to run as an apartment price predictor. And we are going to connect the API that we built today to our user interface, such that when a user inputs certain parameters, the request is going to go directly to our API, and the price of the apartment that was predicted by our model is going to be returned as a response to the user. If you liked what you saw today and if you learned something new, if you would like to also see more applied data science content in the form of such practical tutorials, then please hit the subscribe button and see you next time.